6.1, introducing the quadratic formula. This used to be my most favorite part of working in algebra because this is where you get to test your arithmetic, okay? Obviously, right here in the top, that's my standard form, okay? Right here, this is my completing the square, okay? We can make that little note. My completing the square. And next, we're gonna cause chaos with the quadratic formula. Now, I'm not gonna go into super big specifics with this worked example because I don't wanna scare anybody. We already went over this part, and now they're using this part to create the quadratic formula. Now you're gonna get all the way down here to the bottom, and because of this plus and minus sign, you have to do one plus and the other one minus, okay? Of course, this is not how we're gonna leave it. The way you're gonna leave it is all the way down here. There's that beautiful monster right there. This is my favorite because you will always get the correct answer no matter what. You don't have to worry about graphing. You don't have to worry about completing the square. You will always get the correct answer using this formula, which is why it was my favorite part. I would always use it. It would always give me a lot of math to work with. So if you love math, you definitely want to make sure you're understanding every piece of what we're about to do with this formula. Coming to the top. The equation known as the quadratic formula is right there. Usually I like to write it x1 comma 2 because we're finding two answers because of the plus or minus, okay? Not gonna rewrite it. I just wanted to show you this x1, x2 part. If you look at the example, they have negative 4x squared minus 40x minus 99. Let's see what they do. They label real quick. This is my A, my B, my C, which is all labeled out right there for you. Next, they use the quadratic formula to start substituting numbers correctly. Boom, boom, boom. They start reducing. Boom, boom, boom. They find a small piece. Looks terrific. They get rid of the square root, which becomes that 4. Looks wonderful. Then they split up plus minus your two x's. Then they reduce, they reduce, they reduce. Boom, boom, boom. Check mark, check mark. They found our two x's. Don't forget that this is basically what we always do when we get our graph. You can probably graph this. It'll probably look something like, let me think real fast. I don't want it to be wrong. Oh, it's probably on this side. So it probably looks something like this. And those are my x-intercepts, okay? So what we just found, just using the quadratic formula, are my x-intercepts. It should look something like this. Obviously, if you don't trust me, which I hope you do, you're gonna put this into Desmos, click your zeros, your x-intercepts, and you should get those two answers, okay? Pretty cool, very, very nice. Now let's give it a try. Of course, don't forget you can always pause the video. Don't be afraid to pause the video. This is gonna be the best part ever. Okay, not gonna read all that stuff. Of course, if you want to, you can. Oops. Usually they're always gonna give you the quadratic function. Hopefully, in this case they did. Gonna highlight it so you know exactly where it is. I have to be honest with you, I don't know where they get this negative 16 from, but we're just gonna go with it just because. For part 1, why does it make sense to use a quadratic formula? Because you will always get the answer. You will always get it. If you don't get it, that's because it's not a 0 and your quadratic function is not touching the x-axis, which is something good to know for future reference. Here we go. Use a quadratic formula to solve. Let's see if I have enough space right here. Should. Here we go. Rewriting the equation. H of t equals negative 16t squared plus 91t plus 5.5. Okay, first step is to label A, B, C. We could even write it out just to make sure. A is negative 16, B is 91, and C is 5.5. Where did I get the ABC from? From the standard form in the very beginning, where it was f of x equals ax squared. Can you see that? Nope. Ax squared plus bx plus c. Obviously, if you don't have one of these things, you'll use 0, which we'll go over in just a second. Next, I gotta use the formula. Of course, like I said, I like to write it as this. x1, x2 equals negative b plus or minus the square root of b squared minus 4ac over 2a. Pause the video if you need to. I always get questions, sir, are that 4 and that 2 always going to be there? Yes, no matter what. It comes from the proofing. Next, I'm going to write it to the side because we are running out of room. Instead of these variables, I'm going to write some parentheses. Negative parentheses, sorry. Negative parentheses because of the negative right there. Plus or minus the square root of, parentheses to the power 2, minus 4, parentheses, 2, parentheses. Replace the variables with parentheses so I could put some numbers in the parentheses. And then we just go in order. B is my first one. So I go up here to the where my ABCs are at. Let me see if I can make some room right there, kind of. We should know that first one's A. Okay, so B is my first value, which is 91. So I'm going to put 91 right there. B is my second value, also 91. A is first. A is negative 16. And then C is 5.5. On the bottom was 2A. Who was our A value? Negative 16. And now we start reducing, okay? So it's gonna be a nice process. You just gotta be very, very careful when you're doing the arithmetic, okay? Let me make sure. Hate to give you all some wrong information. Always double, triple check. Okay, here we go. Reducing. Negative times 91. Negative 91 plus or minus the square root of. Need a calculator. I'm going to put what's inside the calculator all together just so we don't have to waste too much time. I'm going to put 91 squared, just like how I see it. Parentheses 91 squared minus 4 negative 16 5.5. Get that wonderful number, 8,633. 2 times negative 16, you get negative 32. Okay, next, it looks like we're gonna get an irrational set of numbers. We do 2, our plus and our minus. Negative 91 plus the square root of 8,633 over negative 32. And then over here, negative 91 minus the square root of 8,633 over negative 32. x equals x equals. Of course, all we got to do is put this in the calculator. You can do it just like this. Remember, alpha y equals enter negative 91 plus the square root of 8,633 over negative 32. Enter. Enter is negative 0.0598. 0.598. Basically 0.06, but we'll leave it like that. If I wanted to, I don't want to waste time. I'm going to go up there, copy that, change the plus to a minus sign. 5.747. Now, our answers are irrational only because our 8,633 is not a perfect square. It gives me a decimal, and I just checked it real fast. If it was a perfect square, we will probably get more than likely a rational number. I'm not going to go into extreme details, the difference between an irrational and a rational number. We just want to make sure you can get your x values. Again, if you really wanted to double check it, all you got to do is come back to the beginning, type this section into decimals, and you should see that your x-intercepts are those exact numbers. Okay, 6.2 will be skipped just to not scare us with all the inner parts of what exactly the quadratic formula is, and we're going to skip to 6.3.